So this is the 40th video on relative velocity. This is in continuation with the 47th video. Okay. So in this also we take up some more problems on riverman problem. Alright. So before going through this video, you must definitely watch the 47th video. Then only you come to this. Alright. So what we are given is this. I will take up a problem. Okay. So problem is this. A straight river of width L flows towards east. At a constant speed u with respect to ground. S denotes a swimmer and velocity of swimmer with respect to river is v, say, which is again constant. The swimmer is initially at a point on south bank and swims across the river such that heading of the swimmer is at an angle of theta to the east of north. To the east of north. All right. Now we have to, first of all, what we have to tell, three things we have to find. First is that show the swimming process on the diagram. Swimming process on diagram. Second, find the time taken t by the swimmer to cross the river. And third, find the drift of the swimmer while crossing the river. All these quantities have to be found in terms of u, v, l and theta. Alright. So I'll rub this one, okay? Fine. So I'll draw the diagram, okay? So this is the top view of the river. This is the top view of the river. L is the width of the river. This is the south bank, this is the north bank, this is the river flowing towards east at a constant speed u with respect to ground. This is the south bank, this is the north bank. Initially the swimmer is somewhere here. S is the swimmer. This is the direction normal to river flow direction. This is not the swimmer swims at an angle of theta to the east of north. So instead of F frame we have the ground frame, instead of M frame we have the river frame, and instead of object under consideration we have the swimmer, S for swimmer. Alright, fine. So this is the starting point of swimmer, this is the eastern direction, this is the northern direction. Now the heading of swimmer is at an angle of theta to the east of north. Theta to the east of north, this is north, this is east. Theta to the east of north is somewhere this way. So this is the direction of VSR, that is V. This makes an angle of theta to the east of north. So as discussed in the 47th video, VSR is nothing but the heading of the swimmer. That is the body axis of the swimmer. Body axis of the swimmer is always along the direction of VSR. And this is the VRG, that is U. And vectors of these two we combine. This is the vector VSG. This is the vector VSG. Alright. This makes an angle of phi, say, with the river flow direction. Fine. So we have now to show the one more thing. Swimming process and diagram. So body axis of the swimmer has to be shown. Now the body axis of the swimmer is always along VSR. So it is something like this. This is the head, this is the feet of the swimmer. It is always parallel to the direction of vector VSR. Something like this. Something like this. Something like this. Okay, fine. Like this, okay. So this is a swimming process on the diagram. So the one thing, the body axis of the swimmer is always parallel to VSR. It is moving like this, like this. In top view, this is the body axis of the swimmer. This is along the direction of VSR, and the swimmer moves like this, not like this, like this. Body aligned along this way, and body drifting in this way, along the direction of VSG. Alright, so one thing I have shown already. Now second, what we have been told to do. Second, find the time taken by swimmer to cross the river. So as discussed in the previous video, 47th video, time taken by swimmer to cross the river can be found by one formula: width of the river by component of VSR normal to river flow direction. As discussed in the 47th video, this has to be taken as a standard result. So component of VSR normal to the river flow direction. Alright. So this is just equal to component of river flow, component of VSR normal to river flow direction. Now from this VSR is in this way, river flow direction is in this way. The component of VSR along river flow direction will be VSR sin theta. So this is just equal to V sin theta. One more answer we have obtained. Alright, fine. Then we have been asked to find the drift. Drift of the swimmer starts from here and finally lands here. This is the point just opposite to starting point on the north bank. This is the drift of the swimmer D. As found in the 47th video, drift of the swimmer is nothing but component of VSG along river flow direction into time taken by swimmer to cross the river. So VSG parallel into capital T. Alright, fine. So this I'll grab it, okay. So now how to find VSG parallel? For that what we do, we write down VSG as vector VSR plus VRG, translating frame formula. VSR is nothing but vector V and VRG is nothing but vector U, and this is VSG. Now VSG parallel is the component of VSG along this direction, along direction of VRG, that is along direction of the unit vector E1 hat. Alright, so what we do, we dot this equation with E1 hat. VSG dot E1 hat is just equal to V dot E1 hat plus U dot E1 hat. Now what is VSG dot E1 hat? VSG into 1 into cos phi. VSG into 1 into cos phi, that is VSG cos phi. What is V dot E1? V is in this way, E1 is in this direction. V dot E1 is simply V is cos 90 minus theta. So this by dot product rule, this becomes V into 1 into cos of 90 degree minus theta plus U dot E1. U dot E1 becomes U into 1 into cos 0 degree, that is 1 again. So VSG cos phi, this is the component of VSG along river flow direction, VSG parallel, which is just equal to V cos 90 minus theta becomes sin theta, V sin theta plus U. Alright, fine. So VSG cos phi is this VSG parallel. Alright, fine. So we substitute here. So drift of the swimmer becomes how much? It becomes U plus V sin theta into L by one thing here, there is a careless mistake here. This is V, it will be cos theta, it will not be sin theta, it will be cos theta. Cos theta, no? Because component of Vs are normal to river flow direction. This direction is VRG, normal to river flow is this, VSG cos theta, it will be cos theta, not sin theta, it will less mistake, okay? So this becomes L by what? V cos theta, alright? This is the drift of the swimmer while crossing the river. This is the drift of the swimmer while crossing the river. U plus V sin theta into L by V cos theta. That is the drift of the swimmer while crossing the river. Okay. So all the three things have been found out. Okay. So all the three things have been fully determined. Alright. So this is the drift. Okay. And this is the time taken. This was mistakenly, by mistake it was written as sin theta, it's just cos theta. And drift is this much. Okay. And time is this much. And D is equal to this much. Alright. D is the drift of the swimmer. Alright. Fine. I love this, okay? Now I'll take up another problem on this relative velocity for river man problem. Okay, fine. See, next problem is this. A straight river flows towards east at a speed of u with respect to ground. Okay. S is a swimmer whose swimming speed with respect to river is V. Also, L is the width of the river. Alright, fine. Find two things. First, find the expression for minimum drift of the swimmer minimum drift of the swimmer while crossing the river. While crossing the river. While crossing the river. Minimum drift of the swimmer while crossing the river. Okay, fine. And consider all possible cases. All possible cases. This is the question, alright? This I'll rub it, alright? So see, I'll draw the top view of the situation. This is the river of width L flowing towards east at a constant speed u with respect to ground. S, he is a swimmer. M, we have river frame R. From F, we have ground frame G. Translating frame formula. This is the south bank, this is the north bank. This is the point where the swimmer starts from. Okay. Suppose swimmer starts from here. Now we want the drift of the swimmer to be minimum. Now for that, in order that the drift of the swimmer is minimum, since u is in rightward direction, for minimum drift, the heading of swimmer should be in this direction. Heading meaning what? Direction of VSR. So for minimum drift, VSR should be something as shown here. This is VSR, that is just V. It makes an angle of theta with the normal to river flow direction. In this case, theta degree to the west of north. Alright. So for D to be minimum, D is the drift of the swimmer. D to be minimum. For D to be minimum, drift of the swimmer should be something as shown above. The drift, that is heading, sorry, drift, no, heading, sorry, heading of the swimmer. The heading of the swimmer should be something as shown above. As shown above. As should be something as what? Shown above. Alright, fine. The drift of the heading of the swimmer should be something as shown above. Should be something as what? Shown above. Now we have to find the expression for drift first of all, then we have to minimize it. Minimum drift we have to find. Okay, fine. So now, as we discussed in the 47th video, let D be the drift of the swimmer while crossing the river. Now D can be written as VSG parallel into T. What is VSG parallel? Component of velocity of swimmer with respect to ground along direction of river flow. That is VSG parallel. And T is the time taken by the swimmer to cross the river. Okay. So first we have to find VSG parallel. Alright. So VSG parallel is what? Component of VSG along direction of river flow. Suppose river flow is in this direction. We take the unit vector in this direction to be E1 hat. And unit vector normal to river flow direction to be E2 hat. Alright. So what do? We write VSG is just equal to VSR plus what? VRG. Alright. Now I take the dot product of so this will be written as VSG is equal to vector V plus vector U. Alright. Now I take the dot product of this equation with E1. So this becomes VSG dot E1 hat is equal to V dot E1 hat plus U dot E1 hat. Now VSG dot E1 hat by definition of dot product is nothing but the component of VSG along E1, that is along river flow direction. So this is the quantity VSG parallel. V dot E1 is what? V is this way, E1 is in this way. This is 90 degree, this is theta. So V dot E1 becomes V into 1 into cos of 90 degree plus theta plus U dot E1, that becomes U into 1 into cos 0 degree. Cos 0 degree also becomes 1. So VSG parallel is just equal to, now cos 90 plus theta is known to be minus sin theta from trigonometry. So minus over V sin theta plus U. So this is VSG parallel. Okay. Now we also have to find the value of T. Now what is time T? This other bit, okay. Now what is T? T is the time taken by the swimmer to cross the river. As discussed in the 47th video, time taken by the swimmer to cross the river, that is capital T. Capital T is the width of river divided by component of VSR normal to river flow direction. As that for the diagram which I just rubbed just now, this is just component of VSR normal to river flow direction, which is nothing but V cos theta. This is the expression for T. So this T will substitute here. So drift D becomes U minus V sin theta into L by V cos theta. This is the expression for drift. Okay. Now we have been asked to find the expression for minimum drift. Now see, to minimize D, to find D minimum, alright, we have to find what? D minimum, minimum drift of the swimmer while crossing the river. Now see, before finding D minimum, it's a matter of everyday observation. Suppose the swimmer is fast with respect to river, fast swimmer, energetic swimmer. That is VSR is more than U. Then what can be the minimum drift? 0. See, at best, what can be the minimum drift? Tell me. It is 0. Minimum drift. Person starts from here. That is suppose this is the top view of the river. This is the starting point. This is the final point. This is the south bank. This is the north bank. Swimmer starts from here and just ends up here. Minimum drift will be 0. Okay. So at best, minimum drift can be minimum that is equal to 0. But question is it always realizable? No. Answer is no. It depends on the relative magnitudes of V and U. If V is more than U, that is the swimmer is fast with respect to river, that is swimmer is energetic, then minimum drift can be 0. Minimum is always 0. Okay, minimum drift will be 0. But what if V is less than U, that is river is faster than the swimmer, then minimum drift will be more than 0. So two different cases we have to take. All right. I love this. Okay. So depending on whether river is fast or the swimmer is fast, accordingly D will have certain minimum value. Okay. If swimmer is fast with respect to river, that is energetic swimmer, that is V is more than U, then D minimum will be 0 for certain value of theta. And if river is fast with respect to swimmer, that is U is more than VSR, that is faster, swimmer is not that energetic as then in that case minimum drift will be more than 0. No matter however fast the person runs, but definitely he will drift along the river for some direction for D minimum. Okay. So now D minimum I will take two cases. Case 1. Case 1, VSR is more than VRG. That meaning V is more than U. That meaning swimmer is energetic with respect to river. Fast swimmer. That is more energetic swimmer. Okay. So in this case D minimum will be 0. So in this case we set D minimum to be what? 0. Now the expression of D we have find out. This will set equal to 0. This quantity will set equal to 0. L by V cos theta U minus V sin theta is 0. Now L by V cos theta cannot be 0, so this has to be 0. U minus V sin theta is 0. So sin theta becomes U by V. So for this value of theta, D minimum will be 0. So now you see from trigonometry you know that sin theta is always less than equal to 1. So this has to be less than equal to 1. So U has to be less than V. So this means minimum drift is 0 only when V is more than U. Alright. Only V is what? More than U. Then only minimum drift is 0. So D minimum is 0 only when V is greater than U. Okay. And in this case the heading angle should be theta, where sin theta is equal to U by V. So for this value of theta, for more energetic swimmer and this value of theta, D minimum will be 0. Alright, fine. Now I'll wrap this first column, okay? Now I take another case. Fine. Now I take case 2. Case 2. That is slow swimmer, fast river. Slow swimmer. That is U is more than V. Swimmer is fast with respect to river. Okay. Now in this case it's a matter of observation. Minimum drift cannot be 0, it has to be more than 0. Now in this case what we have to do, we have to find the value of D minimum. Now we use calculus. So D what we have found just now, U minus V sin theta into L by V cos theta. Okay. So when D is minimum, meaning D by D theta of D, this D means drift, that should be 0 from the rule of calculus. Fine. I'll rub this. Okay. So now derivate this. Okay. So this means D by D theta of L by V cos theta u minus V sin theta is 0. L by V is constant, it goes outside. So d by d theta, 1 by cos theta becomes sec theta. So u sec theta minus V by cos sin by cos tan theta barabar 0. Now we derivate this using the rule of calculus. D by d theta of sec theta is sec theta tan theta. This is well known. Minus tan theta का derivative sec square theta it will be barabar 0. Now sec theta goes away because sec theta cannot be 0 for any value of real value of theta. So it becomes u tan theta is equal to v sec theta. That is u sin theta by cos theta is equal to v by cos theta. Cos theta goes away. So sin theta becomes v by u. So when river is fast with respect to swimmer, then d will be minimum when theta is given by this formula. Now see one more thing. Since we have assumed that u is more than v, this means that theta is real. This means that v by u is less than 1. That is sin theta is less than 1. So that means theta has a real value. Theta is some non-zero real. It will be some real value. Okay, fine. Now to find the value of minimum drift, we substitute the value of theta in this, we get d minimum. So d is just equal to u minus v sin theta into L by v cos theta, and sin theta is equal to v by u. Fine. Now rub this, okay? So I substitute this sin theta in this. So cos theta becomes how much from trigonometry? It becomes root 1 minus sin square theta. That is just equal to 1 minus sin theta is v by u. V square by what? U square. This is substituted in this equation. So d minimum value will be u minus v. Sin theta is nothing but v by u into L by v cos theta. That is v times root 1 minus v square by u square. So this becomes u square minus v square into L by uv root under 1 minus v square by u square. So this becomes u square minus v square into L by v times root under u square minus v square. This cancels out. L root under u square minus v square upon v. This is the expression for d minimum when river is fast with respect to swimmer. Okay. So I write down the final answer here. Okay. So this is the expression minimum drift. So we get two values of d minimum. D minimum is 0 if v is more than u, and corresponding theta is sin theta equal to u by v. And d, the second expression for d is L by v root under u square minus v square if u is more than v. Okay. And corresponding value of theta for minimum drift is sin theta equal to v by u. Sin theta is equal to what? V by u. Sin theta is equal to what? Tell me. V by u. Okay. So this is the expression of minimum drift. You can take it as a standard formula. Fine. Alright. So this is the final expression for d minimum. Depending on river is fast or swimmer is fast, two values of d minimum will be obtained. If swimmer is fast with respect to river, then d minimum is this and sin theta is this. And if river is fast with respect to swimmer, d minimum is this and corresponding theta is from this formula. Fine. So in this 48th session, I have fully discussed the river rainman problem. Okay, rainman problem, or swimmer or river problem, boat river problem, they are the same thing. Okay, so that I fully discussed. All right. So that's a closed distance session. Okay. Next session where I'll take up some more problems on relative velocity. Okay, I'll take up relative velocity problems on case 3 that I describe method in 49th video. I state it. All right. I close it here.